Hello viewers, my name is Jeff Odol and this is Chemistry Now. Now tonight we want to look at back titration. Now back titration is a method of analysis where a standard solution is reacted with the analyte, and in this case the standard solution must be in excess so that the excess of that solution will later be determined by another solution so that it is established how much reacted with the initial substance. Now today we have a problem here, and this is a back titration question, and the question reads 0.5 grams of limestone, which basically is pure calcium carbonate, was reacted with 35 cubic centimeter of 0.571 molar hydrochloric acid, which was in excess. The excess acid needed 25 cubic centimeter of 0.416 molar sodium hydroxide to be completely neutralized. Now, the first question that we have here is, using a balanced equation, calculate the moles of excess acid. Now, the question is quite guiding because in a back titration problem, you always start solving from back coming forward, which means that your first equation that you'll be using to solve the problem will be the equation of the last reaction. And you can see that in our case here, the last reaction was a reaction between sodium hydroxide and the excess hydrochloric acid. So first and important, we write that equation. That we have question number 1, moles of excess acid. Moles of excess acid. So we have to write that equation, and that is the equation between sodium hydroxide reacting with the excess HCl, and that one will give us sodium chloride plus water. Now this equation is balanced as it is, and we need to say to indicate that this one was the excess. This is the acid that was left after some had reacted with the carbonate in the limestone. Now to get the moles, first before we get the moles, you can see that the mole ratio in this case is 1:1. So to get the moles of acid, we can get it from the moles of the base because we are given the volume of the base and the concentration of the base. So in this case is 25 multiplied by 0.416, and we divide by 1000 because our volume is in cubic centimeter and the volume has to be in liters in the solution. Now in this case we get the moles to be the moles of sodium hydroxide. If we multiply, our answer is 0.0104 moles. Now, these are moles of sodium hydroxide, and because the mole ratio is 1:1, it is the same as the mole of acid. It is the same as mole of acid because the mole ratio is 1:1. So, this much acid was the excess after reaction with calcium carbonate in the limestone. Now, the second question is calculate the moles of acid that reacted with the calcium carbonate. Now, just to create some space. I hope that is clear. If you have any question, you can put in the comment section. Now, the second question from this problem is calculate the moles of acid that reacted with the calcium carbonate. Now, we know what we poured initially. We know what we poured was 35 cubic centimeter of this molar HCl, and it was in excess. And we've already determined how much was the excess. So to get what reacted is equal to the total poured, the total moles, which you can say that is the initial moles minus the excess moles. Why is this so? Because we know the total that we poured there and we know what remained after. So the difference must be what reacted with the calcium carbonate. So the total moles in our case here, we still use the formula moles is equal to molarity times volume of 1,000, because our volume is in cubic centimeter. If our volume was in liters, we would not have divided by 1,000. So in our case, we divide by 1,000 because of that. Now this one is equal to molarity was 0.571 times the volume that was poured, which is 35. We divide by 1,000. We get 0.0199983 moles. Now these moles were the initial moles. Now to get the moles that reacted with the acid, we have to minus what reacted is equal to this minus the excess mole, which we already determined to be 0 minus 0.0104. So this one, we subtract this. Let me just which is equal now to 0.0199983 minus the moles that was excess was 0.0104, and we get that moles to be, if you subtract, to get 0.009583 mole. Now this is the moles of acid that reacted with the carbonate. Now the next question that we have here is calculate the percentage, or rather the third question is, using a balanced chemical equation, find out the moles of calcium carbonate that was present in the limestone. Now we know what reacted with the calcium carbonate. This is what reacted with the carbonate. This is the acid that reacted with the calcium carbonate. Now to solve that problem, we must write a chemical equation, an equation of reaction. We have to write the reaction between calcium carbonate. The equation of reaction is this, plus hydrochloric acid. That one should give us calcium chloride. And we know that valency of calcium is 2, so calcium chloride is like that. Then it will give us water and carbon 4 oxide. Now this question is not balanced, so we have to balance it. You can see it's also chlorine there, so you have to put a 2 there, and then the equation is balanced. Now you can see that the mole ratio is now 1 to 2. So one mole of calcium carbonate needs 2 moles of hydrochloric acid to be neutralized for that reaction to be complete. Now we know the moles here. That is what we have just worked out here. The moles of acid that react with the calcium carbonate, we have established that this one is 0.00955 moles. Now from the mole ratio, we can get the moles of calcium carbonate in the limestone just by simple cross multiplication. So that implies that is these moles multiplied by 1 divided by 2, which will give us 0.0047925 moles of calcium carbonate. This is the amount of calcium carbonate in terms of moles in that sample of limestone. Now, the next question is calculate the percentage purity of calcium carbonate in the sample. Like I said initially, limestone is impure calcium carbonate, but this question assumes that the acid only reacts with the calcium carbonate in that limestone. Now, to get the mass percentage of calcium carbonate in that sample, this is what you need to do. You need to use this formula. We know that moles, you can get moles if you have, or rather you can get the mass, not the moles, sorry. You can get the mass of a substance if you know the moles and you know the relative formula mass or relative or molar mass. So mass is equal to moles times the molar mass. Now we know the moles, we have worked it out here, which is 0.0047925. And we know the molar mass of calcium carbonate, which is 40.1 plus 12 plus 16 times 3. Those were given. You get 100.1. Now this one gives us a mass of, if you multiply that by that, it should be giving us something 0.04. Yes, 0.047925. 0.4 because of 0.47925 grams. So that is the mass of calcium carbonate in that sample. Now to get the percentage purity is equal to the mass of calcium carbonate divided by the mass of limestone multiplied by 100. So in this case, we have 0.47925 divided by the initial mass was 0.5. This was the mass of limestone multiplied by 100. And the answer should be 95.85%. So we have solved our problems tonight. So for these and more, you can check out our YouTube channel, Chemistry Now with Jeff Odwal, and you can also check the link on the comment section. If you have any question, just put it in the comment section. Welcome.